Okay, so what I want to do in this is we're just going to review the central concepts in the first lesson that we did, which was focused on energy. And some of the questions that have shown up in the chat have to do with how we define chemical systems. All right, and I know that this is a term which sounds really sophisticated, so I want to break it down. The first thing is, and I'll put it over here on the right, is that we're going to define energy as being the sum of kinetic energy plus potential energy. And I didn't really go into that in the first video, but it's important right now that I just introduce that idea that there's two components to energy. That one of them is the kinetic energy, which is the energy of motion, and then the other is potential. So, and the reason this is going to be important is in the next couple of lessons that we deal with. Remember that we're only going to have 2 lessons a week. You need to finish lesson 1 today, and lesson 2 will drop tomorrow morning. Lesson 2 will drop tomorrow morning. All right, so what's the business about the chemical systems? So we can break the chemical systems into 2 types. Type number 1 are what we call physical changes. And I'm hoping that the physical changes issue is going to be the most obvious one. The other category are chemical reactions. And I'm going to abbreviate reaction as RXN. RXNS, reactions. All right. Physical changes. I'm hoping by now you guys don't see this as too much of a mystery. All right. And the model that I used was the transition of a solid into a liquid, and we're focusing on H2O because it seems to me that everybody pretty much knows the physical changes of water. All right. And so we have the solid where all the particles are in contact all the way around. It's a solid, and the particles are all connected to one another. And in terms of a physical change, we can take this to water, or liquid water, excuse me. So, and I've used this model in the classroom a lot, and I hope that you've got the idea at this point that when we go from a solid to a liquid, there's not much difference between the two of them, and that once we have the liquid, we've broken enough of the bonds so that the system can flow. So this is what a physical transition is going to look like, or a physical change. And hopefully at this point you get it, that the potential energy, or let's just start by talking about kinetic energy. So the kinetic energy of the solid is going to be less than the kinetic energy of the liquid. All right, and that should make sense to you. We actually have to warm this up to go from the solid to the liquid. So in chemical systems, when we talk about energy, one of the ways that we talk about it is in physical changes, taking something from a solid to a liquid, or from the liquid to the gas, for example. Now, I think an area that maybe is less clear to you is that we also can talk about how energy changes in chemical reactions. And the example that I want to focus on here is the reaction between oxygen and hydrogen to produce water, H2O. And you guys have been doing this reaction in the laboratory since last August. This is the test for hydrogen gas. All right, and the reason that I use this as an example, therefore, is because you actually have experience with it. This reaction is pretty interesting because it also releases a lot of energy. So if you remember doing this, you had a test tube that had a reaction in it, and then you inserted a flaming splint. And if there was hydrogen gas present, there was a loud plooping sound. Remember that? Loud plooping sound. And that's because in this reaction, you release energy, and which is the reason that you hear this loud popping sound. Now, so like I said, I don't want to go long about this. Basically, in the case of chemical reactions, and this is going to be what we're going to focus on in the subsequent lessons, lesson 2 and lesson 3, that in terms of chemical reactions, the difference in potential energy has to do with the bonds. All right, so in this case, what we're talking about is energy that is either released or absorbed because bonds are broken. Because bonds are broken. Whoops. Let me just fix that quickly. Because bonds are broken and formed. All right? And that's what we have going on here. The oxygen and the hydrogen have their bonds broken. And then over here when we form the H2O. And the difference in energy between that is the energy that is released here. All right? Now, in the case of the physical changes, and this is where I want to finish with the video, we have differences in thermal energy. Differences in thermal energy. All right? That's the situation with this. And to describe this, I'm going to go to a different screen. All right? So, just very quickly, if I have a sample of boiling water. So this is going to be hot H2O. And remember that the boiling point of water is 100 degrees centigrade. And if I put that sample of boiling water in contact with cold water, hopefully it's obvious to you that these two samples are going to have kinetic energy. The boiling water is going to have high kinetic energy. And that energy is going to be much greater than the kinetic energy of the cold sample, right? This one's the hot. And the result of that is that energy is going to move from the sample which is hot to the sample which is cooler. And so we have a potential energy difference here. So we have thermal potential energy which is greater than the potential energy of the sample which is cold. And the result is energy is going to move until basically the two samples are going to end up having the same energy. All right, and with this, I want to conclude the review session. All right, so I'm going to stop the recording at this